Welcome to Daedalus University. I'm Paul Griffin coming to you from Brooklyn. Today we're going to take a look at probability. So let's get started. I've already got the question up here on the big board. A basketball player generally makes 70% of his free throws. What is the probability that he makes exactly 18 out of 45 free throws? So, to get started, notice that a percentage essentially is a probability. A percentage says that for a made free throw, we'll represent that with like a little check mark. That's a made free throw. That's going to happen 7 out of 10 times. Remember, probability in its most basic definition is the desired outcomes over total possible outcomes. So in this case, the desired outcome is a made free throw, and we're going to see 7 of those out of a total possible 10 free throws attempted. We're also going to need to know the probability that this basketball player misses a free throw. So we'll put an X there, and that's a miss. And the probability for that, well, the probability of an event not happening, right? So in other words, the probability of this guy not making a free throw is 1 minus the probability that he makes the free throw. So the probability that he misses a shot is 3/10. Pretty straightforward. Now, we have to think about all 45 free throws. Question 2 here is, what is the probability that he makes exactly 18 out of 45 free throws? I call your attention to this word exactly. Anytime you see the word exactly in a probability question, pay close attention, and we'll see why in just a moment. First, let's think about these 45 free throws. I could write out placeholders commonly used to designate an event in probability. I could write out 45 of these, but that would take all day. So we'll just kind of imagine that there's 45 of them. And what we're saying is the probability that he makes a shot, let's say the first shot, is 7/10. Probability that he makes the second shot is another 7/10, and so on. So the probability that he makes a shot is 7/10. Now we want to see 18 shots made. So essentially what we have here is the probability that a shot is made to the 18th power, because we want to see 18 shots made. Now, because it says exactly, and this is where the word exactly becomes important, we also have to make sure that he misses the other, let's see, 45 minus 18 is 27. So we have to make sure that we multiply that by 3/10 to the 27th. Make sense? Now, this is almost the answer. The only thing missing is a combination. And that's because, think about it, this basketball player could make the first 17 free throws, the first 18 free throws. He could make the last 18 free throws. He could make 18 in the dead middle. He could make them all spread throughout with misses in between. So because we just want any 18 events out of 45, we use a combination. We have out of 45 events, we're choosing 18 of them. Okay? And that's because the order in which the basketball player makes the free throws is not that important. And that's the answer. So the probability that the basketball player makes exactly 18 out of 45 free throws is this. And you can plug this into your calculator. And briefly, you'll notice it's a very small number. It comes out to about 0.002%, which is quite slim. It seems, wow, less than 1% chance that he makes 18 out of 45. And that's because statistically he's supposed to make 70%. 70% of 45 free throws is 31.5. So he should make about 31 or 32. And, you know, there's about a 12.5% chance he makes 31, 12.5% chance he makes 32. And then, you know, just around there at 30, at 33, you have these higher percentages. And what you get is essentially kind of like a bell curve describing his possibilities, right? And on this bell curve, you know, like I was saying, you would see the bulk of the chances that he makes. Let's say right here is what I was saying about 31 shots, right? And that comes out to about 12.5%. So this is called a bell curve, and this is just sort of thinking about our answer above and beyond the Call of Duty here. And then maybe, you know, there's another high percentage that he makes 32 shots, whereas making 18 shots is going to fall down here in this little slim area. In other words, not very likely that he makes 18 shots. That explains why that number is so low. Let's take a look at another question. Continuing to use combinatorics, or specifically combinations. There are 5 Democrats, 7 Republicans, and 6 independents. How many ways can we make a committee of 10 with 3 Democrats, 4 Republicans, and 3 independents? So first word I would call your attention to this is word committee. As soon as you see the word committee, you must think combinations, because in a committee there's no specific order. The members of the committee don't have specific titles. There isn't, say, a president or a vice president, which would make this a permutation. We're just talking about forming a committee, but we have some very clear sort of dictates or restrictions. We want to have 3 Democrats. Well, you know, all we do there is we say we have 5 Democrats, and we want to choose 3 out of them, right? Okay, that'll give us all the different ways we can make a group of 3 out of 5 Democrats. Now, we want that and, notice we want that and 4 Republicans out of 7. So when you have and in probability, you always multiply. So 4 Republicans out of 7 is going to be, well, choose 4 out of 7. So it's 7, choose 4. And again, you can plug these into your calculator. I'm just giving you the basic solutions here. And then similarly, we want 3 independents, so we're going to say times, out of our 6 independents, we're going to choose 3. And that's it. That's your answer. Anyways, a very simple question. And again, this gets you a pretty big number. There are many ways we could form such a committee. Now let's look at one last question, a little bit more complicated. We're going to keep these same politicians. We have 5 Democrats, 7 Republicans, and 6 independents. How many ways can we form a committee of 10 people, again, with at least 3 Democrats? This time, the key word I will draw your attention to is at least. At least is probably the most annoying word to encounter in a probability question, because you really have to think through at least a few steps further than you would other questions. Well, let's think about it. At least 3 Democrats. Well, we just did the way we could have a committee that had 3 Democrats, and that involves starting with, well, we have 5 Democrats, and we want to choose 3 from them, okay? Now, we need 7 more people for this committee, right? And we want those 7 people to be drawn from the Republicans and Independents, no more of the Democrats. So we take the Democrats out of the running, and we have 13 Republicans and Independents, from which we will choose 7. All right, so this is the way that we will have 3 Democrats in the committee. So I'll sort of notate that over here. This is for 3 Dems. But it said at least 3 Dems. Well, that means we could also have 4 Democrats in the committee, right? And we could also have 5 Democrats in the committee. All 5 Democrats could make the committee. So notice this is a times, because we want 3 Democrats and 7 Republicans and Independents. And then we're going to add, going down the row here, if we chose 4 Democrats out of 5. So again, it's 5, choose 4 for the Democrats, times, we still have 13 Republicans and Independents to choose from, but this time we're only going to choose 6. So notice these numbers, this and this. These would have to add up to our 10 people in the committee, because we want to make sure we end up with 10 people in the committee. And notice these numbers up front, they end up being the total, if you added all of this up, 13 plus 5 is 18, right? So that's why this 5 and 13 keeps totaling 18. Just gives you a way to keep track of your numbers. One way to sort of account for what goes in front of the C, the total possible that you're choosing out of, and then another way to account for what comes on the right-hand side of the C. Now to have 5 Democrats, we'll write out 5C5, but of course that's just one. There's only one way to choose 5 people out of 5, and that is to take them all. And then we'll multiply that by, we're going to choose out of the 13, we're going to just choose 5 to complete our committee. So again, this 5 plus this 5 totals are 10. And that's it. So I'm going to put these plus signs, and that means we're taking this and adding this, and then adding this. So the sum, again to stress, I know it's not written in a line, the sum of how many ways we can form a committee of 10 people with at least 3 Democrats is 5 choose 3 times 13 choose 7 plus 5 choose 4 times 13 choose 6 plus 5 choose 5 times 13 choose 5. We had to take into account having at least 3 Democrats, meaning 3 Democrats or 4 Democrats or 5 Democrats. That's it for now. I'll see you in the future.